Our planet is a fragile oasis in the vast cosmic ocean, a shimmering blue world suspended in darkness, teeming with life and possibility. From the silence of space, Earth appears peaceful and serene, but beneath this calm exterior, powerful forces are at work, shaping and protecting our world. One of the most vital of these is an invisible force field, Earth's magnetic field. This shield, generated deep within our planet's core, deflects harmful solar and cosmic radiation, making life as we know it possible. Recently, NASA's swarm satellites detected a faint, troubling signal, a rapid weakening of this shield over North America, a region critical to both natural ecosystems and human civilization. What's happening isn't science fiction but a real, subtle shift with enormous implications for our daily lives and the future of our planet. The magnetic field, our silent guardian, is showing signs of fatigue, especially across a vast region stretching from the Arctic Circle down through the United States, affecting millions of people and countless species. Scientists at NASA's Goddard Space Flight Center first thought it was a glitch, a temporary blip in the data. But the evidence was undeniable, a significant and persistent decline in magnetic strength. This great North American anomaly challenges our assumptions about the stability of our planet's protective bubble, raising urgent questions about what comes next. Our technology, power grids, satellites, communications, relies on this shield. Without it, the systems we depend on every day become vulnerable to disruption. The weakening isn't a distant problem. Its effects are already beginning to manifest, from increased auroral activity to unexplained power outages and communication blackouts. Understanding and adapting to this new reality is one of the most critical challenges of the 21st century, demanding global cooperation and scientific innovation. The news didn't come with a bang, but with the quiet hum of supercomputers and the urgency of discovery, as researchers race to decode the message hidden in the data. The cosmos has whispered a warning, subtle yet profound, and it's time we listen, before the whisper becomes a roar. Imagine Earth as a giant bar magnet, its magnetic field forming a protective bubble, the magnetosphere. This invisible shield wraps around our planet, deflecting harmful solar radiation and cosmic particles, making life on Earth possible. NASA's swarm satellites have found a massive dent in the shield over North America, with field strength dropping nearly 15% in just a decade. This rapid decline has caught the attention of scientists worldwide, raising urgent questions about what's happening beneath our feet. This isn't a global decline but a localized magnetic valley centered over Hudson Bay, stretching south into the US. The anomaly covers a vast area, affecting millions of square kilometers and potentially impacting countless lives. The speed and focus of this change are unprecedented, a geological event on a human timescale. Never before have we witnessed such a dramatic shift in such a short period. The culprit? Shifts in the flow of molten iron, deep within Earth's core, disrupting surface magnetic patterns. These turbulent currents, hidden far below, are responsible for generating and maintaining our planet's magnetic field. The ground beneath us is dynamic, and this anomaly is a new kind of geological hazard, silent, invisible, but deeply consequential. Unlike other natural threats, we can't see or feel it, but its effects could ripple through our modern world. Unlike earthquakes or hurricanes, this won't shake buildings, but it will impact the technology that underpins our society. Power grids, navigation systems, and communication networks could all be at risk. Our high-tech world is suddenly vulnerable to forces we're only beginning to understand. The very systems we rely on every day could be disrupted by changes in the magnetic field. The cosmos is reminding us. Our technological prowess is still subject to nature's fundamental forces. Even in space, astronauts and satellites must contend with the consequences of these magnetic shifts. This is a 21st century problem, born from the depths of our planet. The interplay between Earth's core and our modern infrastructure is more important than ever. The Great North American Anomaly is a wake-up call for our digital civilization. It's a reminder that we must pay attention to the planet's hidden forces. We must adapt quickly, or risk being caught off guard. Preparing for these changes is essential to protect our way of life. The shield we've always trusted is changing, right now. The future depends on how we respond to this invisible but very real threat. To grasp the anomaly's significance, we look to Earth's magnetic diary, written in ancient rocks. When lava cools, magnetic minerals lock in the direction and strength of the field, revealing a history of weakening, strengthening, and even complete reversals. These pole reversals are slow, messy, and can leave the planet's surface exposed to cosmic and solar radiation for thousands of years. The last full reversal was 780,000 years ago. Geologically, we're overdue. The North American anomaly could be an early sign of such a shift, like the first cracks in a dam. Localized weak spots, here and in the South Atlantic, might be precursors to a global event. For our ancestors, a weaker field meant more auroras. For us, it threatens the technology our lives depend on. We are the first generation to face a magnetic event with a global digital civilization at stake. The stakes are higher than ever before. Our planet's magnetic history is repeating. Only now, the consequences are far more profound. The magnetosphere's main job is to shield us from the sun's relentless solar wind, a constant barrage of high-energy particles streaming through space at incredible speeds. This solar wind is a stream of charged particles that would otherwise strip away our atmosphere, eroding the very air we breathe and making life on Earth impossible. When the magnetic field weakens, more of these energetic particles can penetrate, especially over regions like the South Atlantic anomaly, where the shield is thinnest. This allows auroras to expand their reach, appearing in places they rarely do, and exposes more people to potentially harmful radiation. Expect to see the northern lights dancing over cities like Chicago and Denver, far from their usual polar haunts, but also anticipate increased energy and turbulence in the upper atmosphere, which can have far-reaching effects. This extra energy heats and expands the atmosphere, causing it to swell outward and reach higher into space. As a result, satellites experience more drag, which slows them down and shortens their operational lifespans, requiring more frequent adjustments or replacements. In severe solar storms, satellites could even deorbit and burn up in the atmosphere, disrupting vital communications and navigation systems we rely on every day. The increased radiation also poses new risks for air travel, especially on polar routes where the magnetic field is weakest, exposing both passengers and crew to higher doses of cosmic radiation, which can accumulate over time. Our invisible shield is thinning, and the consequences are becoming more apparent with each passing year. The sky is literally getting closer for our technology, as satellites now operate in a more hazardous environment. The atmosphere still protects us to some extent, but a weaker magnetic field means more radiation reaches the ground, especially at high altitudes and over certain regions. We must now account for what can pass through this thinning shield, as new risks emerge for both technology and human health. The science is clear. Our magnetic protection is no longer something we can take for granted. We're entering a new era of vulnerability, where understanding and adapting to these changes is more important than ever before. The environmental consequences of a weakening shield are complex and far-reaching. Migratory animals, birds, turtles, even insects, use Earth's magnetic field to navigate. A shifting field could send them off course, threatening entire populations. Monarch butterflies, for example, could lose their way, triggering a silent crisis in the animal kingdom. The disruption isn't just about biodiversity, it's about the planet's natural rhythms. Increased solar and cosmic particles can alter atmospheric chemistry, creating reactive chemicals that threaten the ozone layer. More UV radiation at the surface means risks for crops, forests, aquatic life, and human health. We may need to rethink sun protection and daily habits as the quality of sunlight itself changes. The weakening shield could reshape life across the continent in subtle but significant ways. The economic impact of the anomaly is immediate and tangible. Our digital economy runs on electricity, and a weaker shield means even moderate solar storms can overload power grids, causing blackouts. The cost of a major event could reach trillions, with millions left without power. Power companies must invest billions to harden the grid, costs that will reach consumers. GPS and satellite systems are also at risk. Increased radiation can distort signals, disrupting aviation, shipping, and precision agriculture. Financial markets, reliant on precise timing from GPS, could face chaos if signals are disrupted. The cascading effects touch every sector of the economy. Our technological civilization is intricate, but fragile. The Great North American Anomaly exposes vulnerabilities we can no longer ignore. We must act now to reinforce our digital foundation. Daily life may change in subtle ways at first. Glitchy GPS, more frequent power hiccups, and auroras lighting up unfamiliar skies. But as the anomaly deepens, we'll need to adapt to a world where technology isn't always reliable. Space weather forecasts could become as vital as checking the rain. Emergency preparedness will mean planning for extended outages and digital disruptions. Airlines may reroute flights, and health risks from increased radiation will need careful monitoring. Living under a weaker shield is a call for resilience, personally and as a society. It's also a chance to reconnect with our planet and the cosmos, inspiring new generations to understand and protect our world. The challenge is real, but so is the opportunity to grow wiser. Despair isn't an option. Adaptation and innovation are. We must retrofit our infrastructure, hardening power grids and shielding satellites. This is our earthquake retrofitting moment for the digital age. The anomaly should spark new research, better models of Earth's core, more resilient technology, and robust satellites. International collaboration is essential. The magnetic field knows no borders. Sharing data and resources globally is our best defense. Education and public awareness are critical. Everyone must understand what's at stake and how to prepare. An informed public supports smart investments and personal preparedness. The anomaly is a catalyst for technological leaps and global cooperation. Our ingenuity and foresight will define how we meet this challenge. The Great North American Anomaly is Earth's way of reminding us of our place in the cosmos. For all our achievements, we remain deeply dependent on our planet's natural systems. This discovery is a call to listen, learn, and act. Staying informed and supporting science is everyone's responsibility. Our future depends on wise decisions, investment in research, and a scientifically literate society. The story is still unfolding, and our response will define our resilience. Look up at the sky, see the auroras, the sun, the stars, and remember the invisible shield that protects us. We have been warned, but we are also empowered. The anomaly is not doom, but a test of our intelligence and unity. It's a cosmic responsibility we all share.